Welcome back. Today, we are doing a really deep dive into a company that I think defines resilience. Advanced Micro Devices, or, AMD.
It really is. This isn't just a corporate history. It's a story about being the perpetual underdog for, what, decades?
For decades, always the challenger, always fighting for a little bit of market share.
And now, when you look at them, they're not just participating in high-performance computing and AI, they're actively shaping it. It's one of the most incredible turnarounds in tech.
The hook here is just so compelling. How does a company go through multiple near-death experiences, lose almost every big fight for years, and then come back to completely reshape an industry?
And the power shift is so recent. I mean, you look at 2022, for the first time ever, AMD's market cap actually surpassed Intel's.
Which is just staggering. That's not just a stock price thing. That's the market saying, we believe in your future more than the incumbents.
And that future is all about the data center. Their numbers back it up. In 2024, they hit, over $25 billion in revenue, around 28,000 employees.
But the real story is where they're going, the AI space.
Exactly. These massive deals, like the one with OpenAI announced in late 2025, we're talking about a multi-billion-dollar commitment for 6 gigawatts of AI processors.
When you're making deals that big, you're not the underdog anymore. You're a pillar of the industry.
Right. So our sources today give us that whole picture. The early days, the legal wars, the strategic moves, it all paints a picture of how they got here.
Yeah.
So let's start at the very beginning.
So let's go right back to the beginning, the foundational years.
Right. May 1st, 1969. And it's the classic Silicon Valley story. You've got Jerry Sanders and 7 of his colleagues, all frustrated, leaving Fairchild Semiconductor.
We hear about Fairchild all the time. Intel's founders, Noyce and Moore, they came from there too just a year earlier. What was going on at Fairchild that it was just bleeding all this top-tier talent?
It was a classic case of institutional friction. Fairchild was a giant, a pioneer, but it got slow. It got bureaucratic.
And people like Jerry Sanders, who was famously charismatic and, flamboyant.
He wasn't the type to wait for permission. He and his engineering team felt they could move faster, execute better, but the corporate structure was holding them back. They saw an opportunity and decided, like Intel, to just go build it themselves.
And Sanders' whole philosophy was aggressive from day one. High performance, high risk.
Absolutely. He had that famous quote about how you have to be willing to work hard and take calculated risks. And that really guided their first big strategic decision.
Which wasn't about some revolutionary new chip. It was about quality control.
Exactly. They decided to guarantee their products to the United States military standard, which, for a startup, was a huge and expensive promise to make.
So they were basically eating their initial profit margins just to get a foot in the door.
They were, but it was brilliant. You have to remember, in the late 60s, early 70s, microchips were just not reliable. That was the industry's biggest problem.
So if you're a big customer, especially the military, you can't have components failing.
Right, so AMD comes in, not with a brand new invention, but by taking existing logic chips and just promising they'll be rock solid. They guaranteed quality. That built trust, it built a customer base, and it gave them a revenue stream they could use to fund their own designs.
So they established a beachhead on reliability, and then they started to innovate.
Precisely. Their very first product in 1970 was the AM9300, a shift register. But their first proprietary success came later that year with the AM2501 logic counter.
And then into RAM in 71, the pace was pretty frantic.
It was. By the end of 1971, they'd hit $4.6 million in sales. They were proving they could design and deliver.
But the real game changer was 1975, when they decided to go head-to-head with Intel in the brand new microprocessor market.
This was the big one. Intel had invented the microprocessor with the 4004 just a few years earlier. AMD jumped in with the AM9080.
Which was a clone, right? A reverse-engineered Intel 8080.
It was. That was common practice for market entry. But it immediately set up this rivalry that would be defined by intellectual property.
And that led to this incredibly important cross-licensing agreement in 1976. Why would Intel, the market leader, agree to license its tech to a competitor?
They almost had to. It was because of a key technological change. Microcode.
So microcode is basically software that lives on the chip itself.
Exactly. It translates the complex instructions into signals the silicon can actually understand. And because it was software, it was protected by copyright.
So for AMD to keep making compatible chips, they needed a legal license for that microcode.
Precisely. The 1976 agreement gave them that license. And in return, Intel got access to some of AMD's other designs. It was a détente, really. a necessary evil for both sides.
An arrangement that somehow lasted all the way until 1995.
It did. And it formed the legal foundation for the entire PC industry that was about to explode. And while that was going on, AMD kept growing. They had a joint venture with Siemens. They opened a new plant in Austin.
And sales hit $100 million by 1978. They were getting ready.
They were streamlined, capitalized, and positioned perfectly for the war that was coming.
Okay, so if that first decade was them just, getting their feet wet.
This next part is where the real fight begins. It's basically survival. And it all comes down to one company, IBM.
The IBM PC. When IBM decided to use Intel's x86 chips, they had one very strict rule.
A non-negotiable rule. They would not bet their entire PC business on a single supplier. It was too risky.
So they forced Intel to find a licensed second source manufacturer, and that manufacturer was AMD.
It was. This led directly to that 10-year technology exchange deal in 1982. AMD was now officially licensed to make the chips that would power the PC revolution, the 8086, the 8088, and so on.
They were indispensable, riding this massive wave.
They were thriving.
Yeah.
But inside Intel, the mood started to change by around 1984. They realized AMD wasn't just a backup supplier anymore. They were a competitor, a real one.
And Intel decided they wanted out of the deal.
And they showed it by their actions. When the next generation chip, the revolutionary 8386, was ready, Intel stopped cooperating. They refused to share the technical details AMD needed to make it.
Which was a direct breach of the contract. It was an existential threat to AMD.
Totally. If they couldn't make the 386, they'd be stuck making obsolete hardware. They would become irrelevant overnight.
So in 1987, they fought back. They invoked arbitration.
And Intel's response was, well, the nuclear option. They just canceled the entire 1982 agreement.
And that kicked off one of the longest, most bitter legal fights in tech history.
The arbitration alone took 5 years. It finally came down in 1992. And the ruling was in AMD's favor. The arbitrator agreed Intel had breached the contract.
But Intel didn't stop there. They appealed.
They fought it all the way to the Supreme Court of California, which finally upheld the decision in 1994. AMD was vindicated, but the damage was done.
They couldn't just sit around and wait for the courts, though. That uncertainty forced them into a radical new strategy.
This is the moment that saved the company. They couldn't wait for blueprints that might never arrive, so they had to start designing their own chips from scratch. It's a process called clean room design.
Where we basically have engineers who have never seen the original design try to replicate its function just by observing how it works.
It's incredibly difficult. You're building a compatible chip using your own totally new microcode and internal design. They were betting the entire company that their engineers were smart enough to pull it off.
And they did. By 1991, they had the AM386.
Their own clone of the Intel 386, and the market was starved for it. They sold 1 million units in just a few months. Then came the AM486 in 93, which was hugely popular with big companies like Compaq.
This forced evolution turned them from a second-source manufacturer into a true competitor.
A homegrown competitor. And that led to their first truly in-house CPU in 1996, the K5.
And the name is a story in itself.
The K stood for kryptonite. This is a direct shot at Intel, who everyone saw as Superman. It was AMD saying, we're the one thing that can hurt you.
The competition was heating up. They bought a company called NextGen in 96 for almost $1 billion.
A huge acquisition. They basically bought the engineering talent they needed to create the K6 processor, which came out in 97 and competed really well against Intel's Pentium to SEC.
But the big break came in 1999 with the Athlon, the K7. This is where they intentionally severed compatibility with Intel.
Right. Because of all the legal issues around Intel's motherboard connectors, AMD just made their own, called Slot A. For the first time, you couldn't just swap an AMD chip for an Intel one. You had to choose a side.
A huge strategic risk?
It was. But while this CPU war was raging, they had another big business running in the background: flash memory.
And they decided to sell it off, which seems counterintuitive. Why sell a profitable business?
Because the war with Intel was costing them a fortune. They needed cash and they needed focus. In 2003, they spun off their flash memory division into a joint venture called Spansion.
So they cashed out a huge asset to fuel the main fight.
Exactly. They sold off the rest of it by 2005.
Yeah.
It was a painful but necessary move to pour every single resource they had into winning the microprocessor war. They knew they couldn't fight on two fronts at once.
So after all that, they're laser focused. And then, in 2003, they pull off one of their biggest wins ever with the K8 architecture.
K8 was, it wasn't just them catching up. This was a genuine leap forward. It introduced three really fundamental innovations.
First was 64-bit computing.
The x86 64 instruction set, which they branded AMD 64. This was a huge deal. It broke the 4 GB memory barrier that 32-bit chips had, which was becoming a serious bottleneck.
And Intel didn't have it.
They didn't. Intel was forced to adopt AMD's standard, which was a massive symbolic victory for AMD.
Okay, so that's one. What was the second big innovation?
They moved the memory controller from the motherboard directly onto the CPU die itself.
Which sounds technical, but what does that actually do?
It drastically reduces latency. Before, the CPU had to go off-chip to talk to the memory, which is slow. By putting the controller right on the CPU, data access became way faster. The whole system felt quicker.
So why didn't Intel do that first?
They were kind of locked into their existing architecture. Changing it would have been a huge, expensive headache for them and all their partners. AMD, as the challenger, could afford to take a bigger risk on a new design.
And the third piece was hypertransport.
Right. A super fast connection that let all the components talk to each other. It was all part of this cohesive vision for a more efficient system.
And the products they launched, the Opteron for servers and Athlon 64 for desktops, were incredibly successful.
For a while there, around 2005, AMD was the undisputed technology leader. They launched the first dual-core CPUs for both servers and desktops. They were on top of the world.
But then they made another huge, risky move. In 2006, they bought the graphics card company ATI for $5.4 billion.
A massive, massive gamble, and one that nearly bankrupted them when the financial crisis hit a couple of years later.
Was it worth it? All that debt?
In the long run, absolutely. It was essential. ATI was a graphics giant with their Radeon line. By buying them, AMD suddenly had top-tier IP in both CPUs and GPUs.
And that's where the Fusion idea came from, the APU.
Exactly, the accelerated processing unit. The vision was to put the CPU and the GPU on a single piece of silicon. This would be cheaper, more power efficient, and way faster because they could share data directly.
A vision that would, as we'll see, eventually save the company. But before that, they made another huge change. They stopped making their own chips. They went fabless.
It was a matter of survival. By 2008, building a new fab, a fabrication plant, cost a truly astronomical amount of money. AMD just couldn't compete with Intel's spending power.
So they spun off their manufacturing arm into a new company, Global Foundries.
They did. This let them focus all their money and brain power on one thing, chip design. It was a huge philosophical shift, but a necessary one.
But right after all these big moves, things went south, fast. The bulldozer architecture in 2011 was a disaster.
It really was. It was a totally new design that was supposed to be revolutionary, but it just didn't perform. In real-world tests, it fell way behind what Intel was offering.
And a bad product leads to corporate chaos.
It did. There were CEO changes, massive layoffs in 2011, 2012, 2014. The company was bleeding money and looked like it might not survive.
And the sources say there was one thing that kept them afloat during this dark period.
The semi-custom business. This is where that eye-wateringly expensive ATI acquisition paid off.
They could combine their CPU and GPU technology into a single custom chip.
A custom APU. And they sold those chips to Sony for the PlayStation 4 and to Microsoft for the Xbox One.
So the gaming consoles.
Yes, both consoles, launched in 2013, ran on custom AMD hardware. That business provided a steady, predictable, high-volume stream of cash that acted as a financial lifeboat. It kept them alive and, crucially, gave them the money they needed to fund their next big bet.
So those console deals, they were basically a lifeline. They bought them time.
And capital. The capital they needed for what was basically a bet-the-company project, Zen.
An entirely new architecture, built from the ground up, led by the legendary engineer Jim Keller. The pressure must have been incredible.
Immense. They set this staggering goal for themselves. A 40% increase in IPC, instructions per cycle, over their last generation chip.
And IPC is the real measure of a processor's efficiency, how much work it gets done per clock tick.
Exactly. And 40% is an almost unheard of generational leap.
And they didn't hit it.
No, they blew past it. In 2017, they announced they had achieved a 52% IPC increase.
52! That's a revolution, not an evolution. It put them right back in the game.
It was a fundamental technological triumph. It showed that all the pain and restructuring had paid off.
So what was the magic? What made Zen so good so fast?
It was a combination of things. They moved to a much more efficient 14-nanometer manufacturing process. They introduced simultaneous multi-threading, or SMT, which is their version of Intel's hyper-threading.
So one physical core can act like two virtual ones, much better for multitasking.
Right. But the real secret sauce was the move to a modular, chiplet-based design.
Okay, so instead of making one giant monolithic chip, which is expensive and hard to do without defects,
They started making smaller, modular chiplets, which they called core complex dies, or CCDs. These are much cheaper and easier to manufacture with high yields.
and they connect these little chiplets together to build a bigger processor.
Exactly. Using a super-fast interconnect they called Infinity Fabric. This is the key. It allowed them to scale up core counts for their server chips, called EPIC, much more cheaply and efficiently than Intel could with its monolithic designs.
A massive competitive advantage in the data center.
A huge one. And it powered their new consumer lineup too, the Ryzen chips.
And the market responded immediately.
It was a swift and brutal comeback. By 2019, AMD's Ryzen desktop processors were actually outselling Intel's. For the first time in years, they were winning the consumer market.
And they kept the pressure on. Zen 2 in 2019, Zen 3 in 2020. They just kept executing.
Flawlessly.
Yeah.
And they weren't just winning on core count anymore. By 2020, with chips like the Ryzen 5 5600X, they were competing and sometimes even beating Intel on single-threaded performance, which had always been Intel's stronghold.
And all the while, that semi-custom business, the console lifeline, was still going strong.
Oh yeah. The new generation of consoles, the PlayStation 5, the Xbox Series X and S, even the Steam Deck, they all run on custom chips based on the Zen 2 architecture. It's the perfect dual strategy. Predictable console money funding the high-margin, high-performance CPU war. And that Zen comeback, led by Lisa Su, it just completely changed the game. It gave them the foundation for, well, for what's happening right now.
This massive, almost aggressive pivot into the data center, into AI.
And to do it, they started making some truly monumental acquisitions, starting with Xilinx in 2022.
The price tag on that was just mind-boggling. $50 billion. That's one of the biggest deals in the history of the industry. What on earth did they get for $50 billion?
They got market leadership in a very specific, very important type of chip, FPGAs, field programmable gate arrays.
So for anyone listening, what makes an FPGA so valuable in the world of AI?
Flexibility. A normal CPU or GPU is, its function is fixed when it leaves the factory. An FPGA can be reconfigured, reprogrammed in the field after it's been made.
So you can create custom hardware pipelines for new AI models or specialized networking tasks that are changing all the time.
Precisely. It gives data centers incredible adaptability. So AMD didn't just buy a product. They bought the ability to offer customized, adaptable silicon for any future workload. It's a huge strategic advantage.
And then right after that, another acquisition, Pensando for $1.9 billion. This was for something called a DPU.
A data processing unit. This is another really smart strategic move. A DPU is basically a smart network card that offloads tasks like security and storage from the main CPU.
So it makes the whole server more efficient.
Exactly. It shows that they're not just thinking about selling a CPU anymore. They're thinking about selling an entire optimized data center platform.
And to support all this new hardware, they went on a software buying spree.
This is maybe the most critical part of their plan to take on NVIDIA. NVIDIA's dominance isn't just its hardware. It's the software ecosystem, CUDA, that locks developers in.
So AMD's strategy is to build a powerful open source alternative.
Yes. They bought Nod.ai in 2023, then Silo AI for over $600 million in 2024, then a whole string of smaller AI software companies in 2025. They are buying the talent and the technology needed to make their hardware easy to program for AI.
They even bought a hardware company, ZT Systems.
For $4.9 billion. This shows you the full vertical integration play. They're moving beyond just selling chips to selling an entire fully customized server racks and data center hardware solutions, a one-stop shop.
And all of this leads up to that bombshell announcement in late 2025, the OpenAI deal.
This was the ultimate validation of the entire strategy. OpenAI, arguably the most important AI company in the world, committing to buy 6 gigawatts of AMD's next-gen AI processors over 5 years.
A deal that will be worth tens of billions of dollars. It instantly makes AMD a true co-equal competitor to NVIDIA in the AI space.
And the structure of the deal is just fascinating. It includes warrants for OpenAI to buy up to a 10% stake in AMD.
But only if AMD's stock price hits an incredibly ambitious target of $600 a share.
It's an incredible show of confidence. It directly ties the success of AMD's hardware to the company's future market value in a way we've never really seen before.
But amid all this AI excitement, what about the original fight? The server CPU market against Intel.
They haven't taken their eye off that ball. Thanks to the success of EPYC, they have been clawing back market share steadily. As of mid-2025, they hold about 36.5% of the server CPU market.
Which is a huge number. Intel still has the lead, but 36.5% is a serious, serious position to be in. The comeback is real.
Yeah.
So to really get the full picture of where they are today, you have to look at the whole ecosystem they've built.
Right, it's not just about one chip anymore. It's the hardware, the software, everything working together. Let's start with the graphics side, the Radeon Technologies Group.
They spun that out as its own unit in 2015 to give it more focus.
They did. And its architecture has evolved dramatically. They moved from their older designs to what they called Graphics Core Next, or GCN.
And GCN was a big philosophical shift, wasn't it?
It was. It was all about using the GPU for more than just graphics, for general-purpose computing, GPGPU.
Which positioned them perfectly for the machine learning room that was just around the corner.
Exactly. And their newest architecture is RDNA. The RDNA 2 version, which came out in 2020, was their first real high-end competitor to NVIDIA's RTX cards, with full support for hardware-based ray tracing.
It shows they're still serious about the consumer gaming market, not just the data center.
Absolutely. And all of this ties back to that core concept we talked about earlier, the APU.
The accelerated processing unit, the CPU and GPU on one piece of silicon.
It's the foundation of so much of their success. It simplifies design, it saves power, and it boosts performance, because the CPU and GPU can communicate directly through that high-speed Infinity Fabric we mentioned.
No more slow trips across the motherboard.
Right. And beyond the core chips, they've innovated in other areas too, like FreeSync.
Which synchronizes your monitor's refresh rate to your graphics card, getting rid of screen tearing.
And they made it an open standard VI adaptive sync, so anyone could use it without paying for expensive proprietary hardware.
Which brings us back to their software strategy. It's all about open source.
It's a huge, deliberate choice. A direct contrast to NVIDIA's closed-off CUDA ecosystem. They have GPU open for their graphics tools, things like Fidelity FX Super Resolution or FSR.
FSR is that upscaling technology that gives you higher frame rates with almost no loss in visual quality.
It is. And for the AI and supercomputing side, they have ROCm, the Radeon Open Compute Platform.
So the idea is to attract developers who don't want to be locked into one company's proprietary system.
That's the gamble. Build an open, powerful platform, and the developers will come. And if the developers come, they'll drive demand for AMD's hardware. It's a long-term play.
They're even making their own open source AI models now.
That's right. In early 2025, they announced Instella, a 3 billion parameter language model. It's another signal that they are all in on open standards for AI.
We can't finish talking about their engineering culture without mentioning one fun fact.
The Guinness World Records.
Pure bragging rights. They hold the record for the highest frequency ever achieved by a computer processor.
They do. They hit 8.794 gigahertz with their old FX8350 processor, using liquid helium for cooling, of course. It's just a little symbol that even when the company was struggling for its life, that core drive for raw performance never went away.
So when you look back at it all, from, 1969 with a few frustrated engineers,
To 2025, signing these multi-billion-dollar deals to power the future of AI, it's an incredible story.
and the biggest takeaway for you, listening, has to be that none of this was guaranteed. It was earned through a series of huge, calculated risks.
Every step of the way, the legal fight with Intel forced them to become innovators. The massive debt-fueled ATI acquisition gave them the IP they needed to survive. The shift to a fabless model freed up the cash they needed for Zen.
And that Zen comeback, under Lisa Su's leadership, it just changed everything. It set the stage for this massive pivot into AI with acquisitions like Xilinx.
Their survival has always depended on two things: making big architectural leaps, like with AMD 64 back in the K8 days, and making smart business pivots, like focusing on the console market when the PC market was weak. It's a masterclass in adaptation.
Which brings us to our final thought. AMD's massive deal with OpenAI is tied to its stock hitting an ambitious $600 a share. To get there, they have to become an undeniable leader in AI.
And they've spent $50 billion on Xilinx to get access to those flexible, reconfigurable FPGA chips. Their entire software strategy is built around being open and adaptable.
So here's the question for you to think about. For the last 30 years, high performance computing has been defined by the battle between standardized CPUs and GPUs. But AMD's massive investment in customizable FPGAs suggests a different future.
Is the future of computing going to be another round of the same CPU versus GPU fight? Or is the market shifting to a place where victory belongs to whoever can build the most specialized, rapidly adaptable, custom silicon for every single new AI workload? If that's the future, AMD might be betting that the era of the general-purpose processor is coming to an end.